So thanks, Michael. And I just want to thank NodeConf EU really quickly because it's not often that scientists like myself are given a platform to share their mad ideas, especially us scientists of the mad persuasion. So thank you so much to Kian and to all the NodeConf EU organizers. Thank you. So I want to talk to you guys about WebRTC mad science. So first of all, just a little bit about me. I've been playing with WebRTC for the last year. I started a company to do WebRTC as a CDN, and it was acquired by Yahoo about December last year. And so now I'm a mad scientist in chief at Yahoo. And so let's talk a little bit about WebRTC. So I like it because it enables all sorts of crazy mad science. In essence, it's just a JavaScript API and a protocol that allow you to build peer-to-peer applications in the browser. And the normal use case that you see people using it for is video chat. So, things like Google Hangouts, Talkie.io, and Amazon's Mayday service, which is like a little button you can hit on your Kindle that brings up a video chat with service representatives. So if you're confused about how to use your Kindle, you can quickly get help. But I'm more interested in the data channel because you can build anything on top of it. So the way that Justin Uberti, the WebRTC lead at Google, described it is it's a project to bring real-time communication to the open web platform. So that means that you don't need to install anything, and it's going to be built into all the browsers. It's currently working in Chrome, Firefox, and Opera. And IE is planning to add support soon for this kind of alternate WebRTC API called the ObjectRTC API, which is sort of like WebRTC 1.1 or 2.0. So it's not the worst thing in the world. It's going to be uniform across browsers. And it seems like Apple's actually starting to think about it as well because of this bug report that, or this issue notification that I saw where somebody with an apple.com email address is talking about merging in WebRTC changes. So that's pretty cool. And it works on all sorts of devices, including the mobile versions of Chrome and Firefox on Android. So when I was thinking about what would be cool to build with WebRTC, one thing that immediately came to mind was BitTorrent. So because that's like one of the coolest peer-to-peer applications. And it allows you to do really efficient file transfer and file delivery over this distributed network made up of tons of, millions of people around the world. So essentially, what I want to build is a peer-to-peer YouTube so that we can watch videos like this 10-hour cat fail compilation completely peer-to-peer. Let's watch this one more time just because it's so good. So the way that this will work is we have all these nodes out there that are currently talking BitTorrent, and they all speak to each other, and they all speak BitTorrent, right? But what we need to do is animate this. Yeah. What we need is so there's going to be these kind of web clients that are speaking over WebRTC, and they're going to all talk to each other, and they're going to share files with each other, and it's going to be one happy network. But they can't talk to the BitTorrent nodes because WebRTC and TCP and UDP are completely different. So we need these hybrid nodes, which are going to basically be installed clients that can speak WebRTC to kind of bridge the two networks. But that's kind of like a long-term thing. Just with what we have today, we can actually do pretty awesome things with just the web clients, with just a WebRTC-based BitTorrent network. And as of a couple days ago, I actually got this working end-to-end, and I want to show that to you guys today. It's pretty exciting. So one really obvious use case to use WebTorrent is file sharing. So I have this little site I whipped up. Can everyone see it? Yeah, cool. So we can drag files into this site, and what it does is it actually so it uses drag and drop, and it takes the file object that is provided, and it creates a torrent file for it, all in the browser. And so a torrent file is essentially just, it's a list of hashes for all the pieces in the file. So it kind of splits the file up into these pieces, and then it creates a hash for each of them. So when you're receiving bits of the file over the network, you can kind of check each of the pieces independently and make sure that they're what you expect. So if you have the torrent file, you can get the data from any peer, and you can ensure that it's correct. And the reason why we need a lot of these hashes is because if one of the pieces is wrong because the peer gave us the wrong data, we can just throw that piece away without re-downloading the whole file. We can just refetch that one piece that was incorrect. So that's what we did here. And then I'm going to take this hash, which is kind of like the top-level hash that describes the whole file. This is kind of how magnet links work, if you're familiar with those. Who here has used a magnet link to download a torrent? OK, cool. So a magnet link is basically just an info hash in a URL form. So I'm going to paste that over here, and I'm going to say, let's download it. Now, if the network cooperates with me, you can see some stuff's going on. Yeah, there we go, cool. So that was downloaded directly browser to browser using the BitTorrent protocol. So now if I click this link here, we can see that the cat was sent through the internet. Yes, it worked. Cool. So the code for this is actually really, really simple. Let's take a look at how it works. So we have, first of all, we need to do drag and drop, right? So there's this nice little module called drag drop, which does that for you. And I'm including the /buffer version of it because I want to get back the file data as a Node.js style buffer rather than the weird kind of file object that the browser normally gives you. So it's just a callback. This will get called when the user drops the file. And then all I'm going to do is I'm going to include this module that is called BitTorrent client, which probably should be renamed at some point because it now does the WebTorrent stuff as well. And just going to initialize the client, and then I'm going to call client.seed. So this is the person who's dropping the file. They're going to begin to seed the file. They're the initial kind of hoster of the file. And then this callback gets called once they've begun seeding it, and all I'm doing is just printing out the hash so that they can paste that to their friend. And then now on the other end, the user who has the hash is going to paste it into that little input box that we saw. So I'm just adding a listener on the input box for the submit event. And once the form is submitted, I just add the torrent to the client. And so the way that I'm describing this torrent is in this object. So it's composed of two parts. There's the info hash. And I have to manually specify this tracker here. This is a tracker server which is used to coordinate the peers. You could also use a DHT, or a distributed hash table, to coordinate the peers. But for here, we're just going to use this tracker server. And this event will fire once we have metadata for the file. So metadata is sort of like you have the torrent file itself, which contains like all those pieces we talked about. It also contains a list of all the files and file names that are in the torrent. So we just have one file in our case. So we just loop through those files, and we can create a read stream on each of them. And what are we going to do with the read stream? Well, let's pipe it into concat, and then it'll give us a buffer once the file has been completely streamed. And then let's just create a link to it and insert it into the DOM. So that's what we just saw. Oh, I should demonstrate, since we have this for each loop here, we can actually do multiple files. So if I go back here and I drag all these files in and drop it, we should get, with one torrent file, we're describing all of those files. The network is a little slow, so once the peers connect to each other, it's pretty fast. That video is pretty big, so it's downloading. There we go, cool. Anyway, so that works. That's not that much code and pretty powerful, I think. So yeah, so even without those hybrid nodes, bridging the two networks, you can still do pretty useful things with WebTorrent just by itself on the web side. There's also a command line application that you can use, which is a Node app that gives you a little command line program. And you can invoke it like this with magnet URI or a torrent file, and you can say --VLC, and it'll stream the movie into VLC if it's a movie. And what's cool is that client actually talks to both networks This is one of those hybrid clients. So hopefully in the future, all torrent clients will be hybrid like this, and we'll have one big network comprised of BitTorrent and browsers. So one thing you might have noticed was I required a module called BitTorrent client. And that's actually the same module you would use in Node if you wanted to do BitTorrent in Node. How am I using the same module in Node and the browser when they're completely different environments? That's pretty crazy, right? So the dependency tree looks something like this for that module. It's composed of a bunch of little pieces that are all that implement all the different functionality that you need to build a BitTorrent client. And when it comes time to bundle it for the browser, we use Browserify, of course, and you can use this great thing called the browser field. So with a little declaration like this, you can say, instead of requiring the module on the left, please instead include the module on the right when you're bundling this for the browser. And so it turns out that we can actually keep most of the code exactly the same in both places because we designed it in a really nice modular way with clean interfaces between the layers. And so at the very top layer, you have the main BitTorrent client module, which implements all of the logic for picking which pieces to request from peers and all the kind of complex coordination of all these modules. And at the very low layer, we have this protocol module, which can speak the wire protocol. And that's the kind of, that's kind of just like a stream that you have with a remote peer. And it doesn't care what the transport is. And so you can do this crazy thing, which is replace a module that's sitting between those two layers. And as long as it has the same API for both WebRTC and for TCP, everything will just work. So that's how that mad science works, and I think it's pretty cool. So with just like this one change, I made this library work in both Node and the browser. So that's WebTorrent. I want to also, not just talk about WebTorrent. I think it's cool, but I think we should build a WebRTC app together, so you guys can kind of get a sense for how that works. So I thought, why don't we build a real-time whiteboard? So I want a whiteboard that we can all draw on together, and I want to see what you guys draw. Please keep it family-friendly. There might be kids in the audience. I know you guys are responsible adults, some of you. So let's do this. So first off, let's just ask the user for their name so we can show like a list of the users that are on our whiteboard. So we're just going to prompt them using the prompt method and kind of loop through, so the user has to really give us their name. And then let's pick a color. So every user who joins our whiteboard will get a random color assigned, so we can kind of distinguish who's drawing what. And then I'm just going to create some little variables for storing various pieces of state. So as you're drawing, I want to be able to send the points across to all the peers live, so that you don't have to finish a stroke before it shows up on everyone else's whiteboards. They'll see your line kind of being drawn as you go. And so to do that, we store like the current ID of the path that we're creating in this little variable here. Then we have an object for storing all the state, an array of peers, and then we're going to give ourselves an ID, a randomly generated ID, so people can refer to us with that ID. And then let's create a canvas and get a context for that, add it to the DOM, and then set up the canvas. And we'll add a little listener, so anytime the user resizes the browser, we reset up the canvas. And to set up the canvas, we're just going to do this kind of gross hack to make it look nice on Retina displays. Don't worry about it too much. Set a bunch of stroke options and font options so our canvas looks nice. And we have this redraw method, which is going to get called anytime the state changes. So that just clears the canvas, and then it loops over the state object that we set up earlier. And the way the state object works is the keys are just IDs. So every item that's on the whiteboard is just going to have an ID, and then a value, which is, in the case of a stroke, it's just going to be the value as an array of points. And so as someone's drawing, they keep sending us new points, and we just keep appending it to this array of points that we've collected so far for that stroke. And then we just loop through all the points and begin a path, set the color to be the user's color, and draw it, and then we're done. And then we draw the usernames as well. So peers is a list of all of our peers. We add ourselves to that list. So we add our color and our username, and then we loop over and we just draw our username to the screen. So let's see what that looks like so far. So I have a local copy running right here. So if I refresh this, yeah, there we go. So I load it, I get prompted for my name, I'll say Feross, and then we have a canvas here, and my name shows up down here in the bottom. I don't know if you guys can see that. There we go, cool. So now let's actually implement the drawing code. That's pretty easy. We just add some event listeners for mouse down and touch start. And we get the X and Y point where the user's drawing. I'm actually creating 2 points here because you need 2 points for a line to be drawn so it looks like a point. So I'm just kind of making 2 points that are really close to each other so a point shows up when you first click. And then I add that to our state object, and then I broadcast it to everybody. So I have this broadcast method, which we'll implement in a bit. And then we redraw. And then when the user lifts their finger up from the screen, then we null out the path ID. And as they move, if there is a path ID, so if they're moving the mouse and they have clicked down, then we want to keep creating points. And so we do that here. We create points and we add them to our state object and we broadcast that to everybody. So let's see that working. So broadcast right now isn't doing anything. But I should be able to draw locally. And yes, I can. That's cool. I'm such a good artist. Oh, yeah. Thanks. Cool. So now let's actually let's write that broadcast method, and then let's also handle the messages that our peers send us. So for broadcast, it's really easy. We just loop over. Oh, actually, first of all, how are we going to connect to the peers? We haven't talked about that. So where is that? Here we go. OK, so this is kind of hacky. So basically, the way you want to have peers talk to each other is you need the peers to send some what's called signaling data to each other. I don't want to get into it too much. I've talked about it at other talks. Go watch my LXJS talk if you want to really see how it works in detail. But basically, the gist of it is that you have to do this kind of crazy sequence of events where you create a peer connection object, which represents a connection to a peer, a remote peer. And then you have to ignore add stream. That's if you're doing video. We're not doing that. You have to create an offer. You have to send that offer to the other side. They have to create an answer and send it back to you. And then you have to send these candidate things, which are basically IP port pairs, across. And then eventually you can create a data channel. And then you can send messages. You call send on one side and then message event emits on the other side. So it's kind of crazy and complicated and annoying. So I wrote a module called Simple Peer, which makes this way simpler. And we're using that. The way that works is you just initialize a peer object, and it will emit signal events, which means there's some data that you should send to the other peer that you're trying to talk to. Don't worry about what it is. Just get it to them somehow, either through a WebSocket server or write it down on a piece of paper and send it to them or IM it to them, whatever. It doesn't matter. They just need to get it. And when the other side gets it, they need to call the signal method with that data. And then same thing in reverse. If events get emitted on the other side, just send them across. And then you'll just get a ready event, and you can start calling send as soon as you get that. And the data will make it to the other side just magically. So if you're not doing video, then it's even simpler because you don't have to worry about the stream event. So that's nice. So we're going to use that. But we're going to also cheat a little bit. So rather than write a server that does all that, I'm just going to reuse one of the components from WebTorrent. So we're going to include the tracker module. Since everything's really modular, we can just include one piece of WebTorrent. And all we're going to do is just announce to the tracker that we're interested in a particular torrent, and we're just going to give it a consistent value so that everyone's using the same value. In this case, all zeros. And so once the tracker logs the fact that we are interested in this 00000 torrent, it will add us to a list, and anyone else can say that they're interested, and then these peer events will get emitted. And they'll get past an instance of that simple peer object that we talked about earlier that's all ready to go for us. So this is kind of hacky, but it works. So let's just go with it. And to broadcast, we just loop through that object and call send on each of the peers. Really simple. And we need to handle, so whenever we get a peer event, we need to do a few things. One is add it to our peers array, send the peer our username and our color, and our current state of the world. So if a new peer connects, they can start with the state of the whiteboard that everyone else sees. And then when we get messages, we're going to call this function we'll implement in a second. And when the peer leaves, we just remove them from the peers array. Cool. So what do we do when we get a message? Well, if the message contains a username, then we just like add that username and add the color to the user. If the user sent us a state object, then what we do is a little bit clever here. So since this world this whiteboard is peer-to-peer, it's sort of eventually consistent. Everyone's going to have like slightly different versions of the whiteboard at different times. And so what we want to do is every time someone sends us their state of the world, when we first connect to them, we want to loop through and see if they have any IDs for strokes that we haven't seen. And if they tell us about a stroke we haven't seen, we want to add it to our local state. So that's what this does here. And then we redraw. And lastly, if we're getting messages that are just containing points, individual points, then we want to append those points to the array of points that we have for a stroke that's in progress. And with that, we should have a shared whiteboard that's working. So let's see how that works, if it works. So I'm going to try and create a bunch of windows here. Okay, cool. So let's load this up. Oh, cool, yeah. So I left the world, but the state already started to get synchronized over. So this guy, I just refreshed him, so he should get the state in a second. Yeah, there we go, cool. So everyone has the same view of the world, and if I draw in one, everyone is getting the updates. That's awesome. Everyone has a different color. Sweet. And I should be even able to pull out this Android phone here and join. So I'm just going to refresh the page. What is my name? Let's see. Okay. There we go. What is that? You guys don't join yet. Yeah, so my phone has the same state here. See? Cool. Oh, and let me draw on the phone too. So I'll draw like a heart or something. Cool. So this is full mesh networking, which means every peer is connected to every peer, which doesn't scale usually if you're doing video or anything really big, but for just sending little tiny points across, it's totally fine. We could probably go up to a lot of users just fine. So now let's see, what can we do to make this even crazier? How about we support images? So let's do that. So I'm going to add the drag drop module that we used earlier. And what I'm going to do is I'm going to use WebTorrent for the images. So I could just send the image, when I drop an image, I could just send it to everyone I'm connected to. But the problem is, if I drop like a huge image, now suddenly I have to upload it to like 40 people. And my upload speed is probably pretty bad because I'm on a residential connection or whatever. So we need a better way to do it. So what if instead we just create a torrent for the image and just send the hash of it across to the other peer and let them download it using WebTorrent. Then we get nice swarming characteristics where I can send one piece to one person, a different piece to a different person, and then suddenly those two people are now interested in each other because they have pieces that they need from each other, and they can connect, and that's work I don't have to do as the uploader. So it's great. So let's do that. So I'm going to add a little. I'm going to create a WebTorrent client. And I'm going to create this little object to store the torrent data that we've downloaded so we know not to download it multiple times. We'll just kind of cache it in here once it's been downloaded once. And what I'm going to do is use drag drop. And when a file is dropped, I'm going to start to seed it. And once I've begun to seed it, I'm going to convert the buffer of the image file into an actual image tag. And I'm going to cache that in this object that we created earlier, as well as broadcast a bunch of details about it to everybody. So I'm going to say, I just added an image, here's its hash, here's its position, and here's its width and its height. And then I'm going to add it to my own state object, and I'm going to redraw. So the buffer to image code is pretty simple. It just uses the create object URL function. And one other thing we need to do is support this new message type. So when we get a message with an info hash key, we know we just add that to our local state. And then in the redraw method, that's where we actually handle the downloading. So when we're going through our list of things to draw, if we notice that the thing we're supposed to draw is actually something that we need to torrent, then we go out and get it if we haven't got it already by calling client.download. And once we have the torrent metadata, we just create a stream, pipe it into concat, get back a buffer, turn it into an image, and add it to our cache. And while we're waiting, we also draw like a little rectangle to show kind of like a placeholder of where this image is going to end up. And here's where we actually draw the image once it's complete. So let's see how that works. So it turns out I'm actually running the final version of this code already. So I'm just going to drop an image in. So I'm going to just drop it right here. And these other clients should get it if everything works. Yep, nice. Except this guy's not working. I got all this working like a day ago, so WebTorrent is super alpha quality, fair warning. And I'm going to see if it works on the phone too. So let's see. I just refreshed the page on the phone as well. Should get the image. There we go, cool. So. Now, one thing that we can do that's insane is we can open up the console here and find out what the hash was for that image. And so we can find out the hash of the torrent. And we can do something crazy. So I'm going to look through the logs here and find where that image was created. Here we go. So here's the hash of that cat picture. Now I'm going to go over to Instant.io, the site from earlier, and I'm going to say I want to download that. And I'm going to paste in the hash here. So this should work. So what it's doing is it's actually connecting to all the whiteboards that are open right now, including the one on this phone, and it downloaded the cat from them, even though I'm on a different domain. So I'm on Instant.io here, and all these other websites, this is a different domain here, localhost 3000, and these clients are actually seeding to anyone who wants it on any site. So if I click this cat, it should load, and it does. Cool. So there's actually no same origin policy. So this means you can actually think of the WebTorrent network as a completely web-wide network that spans all sites. And this works because in order for JavaScript code in the different sites to create WebRTC connections to each other, both the sites have to want that. They have to include all that code in their site. And so there's really no reason to enforce the same origin policy. You only have WebRTC code in your site, and you only accept connections from people if you want them. And so that's really cool. So last thing I want to do, how am I doing on time? Do I have another minute? Oh, OK. Well, should I stop? OK. I'm gonna show one last piece, which is let's add video to the whiteboard. So we're going to just make a couple more changes. So when we drop files on the browser, we're just going to check to see if they're WebM files. And if so, we're going to say, OK, that's a video. And we're going to send the hash of the video across and just note that it's a video. And when we receive messages, where's that on message here? Nothing changes, so it's still torrent, so we just add that to our state. But when we get to the drawing code, there's a few changes. So the drawing code is right here. So we note that we're trying to, let's see, where's this at? Yeah, here we go. So we torrent it just the same, but then once we actually have the metadata, we just kind of mark it as a video stream. And then when we go to draw it, we don't call the canvas draw image method. Instead, since canvas can't really draw video, we're just going to create a video DOM node and place it on top of the canvas. And we're going to use this crazy API called media source, which actually lets you append video chunks to a video tag and sort of stream video in. So if you have a piece of a video file in JavaScript, and you're progressively getting more pieces over time, you can just keep appending them to a video tag and stream it into a video. So we just check to see that we don't already have a video tag in the page, and so we create a video element, position it, turn on the controls, append it to the page, and then we call pipe to video, which is just this kind of method that takes a stream with video data and then pumps it into a video tag using the media source API. It's a little bit gross, but the important part is just right here, where we just kind of pipe each of the chunks into this array, and then we take them out of the array and just append them to this source buffer thingy that ends up playing it in the video tag. Cool. So let's see that work. So I should be able to drag this video in. Let's try dropping it in a different window right here. Cool. So it's playing over there. It should eventually end up. Yeah, there we go. So the network is a little slow here, but it'll eventually make it to all the tabs. And it will make it to the phone eventually, too. The phone keeps going to sleep, so I have to keep refreshing the page when I wake it up. But looks like I have a bug where it only makes it to 3 of the 4 windows, but it can be fixed. Anyway, so that's streaming video. And what's cool about that is it's actually not fully downloading the video before it starts to play it. It's just a node-style stream. So as it gets the pieces of the data in, it's prioritizing the pieces that it fetches. It's fetching them sequentially from all the peers, and then it just, as it gets each one, it pipes it into the video tag. So if this was like a 20-minute movie or something, you could start to watch. The peers could start to watch immediately, which is pretty cool. So that's basically my demo. If you guys can really quickly go to this URL, we can see if this will work. Oh my God, there's going to be way too many people. How about we rate limit it? Only 5 join at first, and then another 5, because I've never tested this with more than a handful of people.
The internet will probably go out.
The internet will probably go out, yeah. Let me also refresh this page. I want to kill the state, so we start with a fresh whiteboard. So if every peer leaves, then one cool thing that happens is the state is lost. Some peer needs to be holding on to it in order for it to live on. So hope this works. Something's happening. Oh, cool. Connected to somebody. Jonathan. Who's Jonathan? Raise your hand. Ah, there you are. Oh, whoa, okay, we got a bunch of people. All right. Nice. Everyone's sending their state once they join to me. So I'm just adding the strokes that I didn't have in my database. So you can see all the points being streamed across here in the console. Anyway, that's my talk. So please build things with WebRTC, and please use WebTorrent, and please file bugs. And there's a bunch of things that need to be done, like documentation and building a native app, and just give it a shot. I think it's pretty cool, and yeah, we need more mad science. So go forth and build mad science. Thanks. Woo!